Okay, so we're going to begin by doing, I was going to say a review, but it's basically a continuation of what we were doing at the end of chapter 4, which was using integrals to accumulate rates. And we're going to be continuing that throughout chapter 5 as well. So a particle moves along the x-axis with acceleration a of t 2 cosine t minus 1, and that's in meters per second squared, with the initial velocity of 3 meters per second and initial position of 4 meters to the left of the origin. Find the position of the particle at t equals pi seconds. So what we need to do is come up with a position function from an acceleration function. So if you have a position function s of t, then take the derivative, you end up with v of t. Okay. Take the second derivative, and you get v prime of t, and the derivative of velocity is acceleration. So acceleration is the second derivative of position because acceleration is the rate at which the velocity changes. It's how quickly if you want to think about it like in layman's terms, it's how quickly your speed changes. So that's why acceleration is a component, not the main thing, but it's one of the components of whether a particle is speeding up or slowing down. Because it's, speed or velocity by itself does not tell you whether a particle speeds up or slow down. There needs to be an acceleration component to be a part of that. So acceleration is the rate at which the velocity is changing. So what we need to do is now, instead of like finding derivatives, we're going to be finding antiderivatives to go backwards to get the position function. So we're going to start with a of t, which I'm going to go ahead and just rewrite. Okay. And then to find the antiderivative, we find velocity. The antiderivative of cosine, so what derivative gives me cosine? And that is sine. Antiderivative of -1 would be negative t. And then don't forget to put plus c. Okay, do not plug in your initial velocity or initial position as your plus c. You need to solve for c. Okay, so 3 is my initial, and you need to show this work on any assessment. So 3 is the initial velocity. So 3 is the velocity when t is 0. Okay. And then sine of 0 happens to be 0. So c does equal 3 in this instance. It will not always be your c value, which will, spoiler alert, show up here in a second. But c is not necessarily your initial velocity or your initial position or whatever. C is just a constant. So plug the values in with t equals 0 if you're given the initial. Sometimes they'll give you like, the velocity at 1 second is 3, and then you would plug in t equals 1 or whatever. Okay, so then I get velocity is 2 sine t minus t plus 3. All right, so now I'm going to find the antiderivative to find position. So the antiderivative of sine of t would be negative 2 cosine t. Because remember, the derivative of cosine is negative sine, but this is a positive sign, so I have to make it a negative cosine. Minus 1/2 t squared plus 3t plus a different constant. Okay. And then again, we're told the initial position is 4 meters to the left of the origin. So left of the origin would mean my position initially is -4. So don't forget to, keep track of your positives and negatives. And I am going to plug in, because it's an initial value, I'm going to plug in t is equal to 0. So I get -4 is equal to, okay, cosine of 0 is not 0. Cosine of 0 is 1. So this is one of those instances, and then -0 plus 0 plus c. This is one of those instances where c does not equal the initial value. If I add 2 to both sides, I get -2 is equal to c. So please make sure that you plug in t equals 0 and show that work. Make sure you write out what the equation is. And then we're finding the position at t equals pi. So it's negative 2 cosine of pi minus 1/2 pi squared plus 3 pi minus 2. I can't simplify much of this. So the only thing I can really do here is figure out what cosine of pi is and then maybe subtract 2 from that. So I get s of pi is equal to negative 1/2. I'm just going to kind of do this out of order. Negative 1/2 pi squared plus 3 pi. And then cosine of pi is negative 1. Negative 1 times negative 2 is positive 2. Positive 2 minus 2, oh, that part actually goes away. So s of pi is just this. And you do not need to plug this into your calculator. Just don't round. If you can leave it in exact form, you should. Is it the prettiest answer? No, but that's okay. I'm done. Move on. You don't need to do other stuff. Just move on with your life. Okay? So just remember, when you are finding antiderivatives, you have a plus c. You need to plug in the time and the value that you're given and solve for C. And you need to show that work. Even if you expect that C is the initial value, you still have to prove it by plugging in t equals 0 and showing that work, especially because sometimes C is not the initial value. All right. And that's it.